Lesson 10-2 is about measuring angles and arcs. You're going to have to really think about way back in pre-algebra when you first learned about finding the degrees of a circle chart. Okay? First thing we need to remember though, the sum of central angles. Now this is the central angle where the vertex of your angle is at the center. So what do you think all three of these angles are going to add up to? We got the measure of angle 1, measure of angle 2, and the measure of angle 3. Those are all going to add up to 360 degrees. That is our magic number when talking about circles. Okay? So, example 2, find the value of x. I've got a bunch of different central angles. I've got 1, 2, 3, 4, but I'm missing this one right here, QTR. Well, if I look at QTR, I can see that it is the same as this angle right here, UTV, because it's vertical. Those two angles are the same, so I can use this measure, 5x plus 5, for this angle. And what do all of my angles add up to? 360. So let's make an equation. I've got this angle right here, 5x plus 5, plus this angle right here, 8x minus 4, plus this angle right here, 13x minus 3, plus another 5x plus 5, and then plus this big, huge angle, 20x. And let's set all of that equal to 360, because we're going all the way around. Okay, let's combine like terms on the left side, and we will get 51x plus 3 equals 360. Do a little algebra, minus 3. And then let's divide by 51. And we will see that x equals 7. Now, can I use that to find these angles? I sure can, but I don't need to. I just need to know what x is. But if it asked me to find the value of each angle, I could just substitute it in and find out each one. You're going to start seeing theorems again, and I know that you're going to love the fact that we're going back to doing a few proofs. I said a few, not a lot. So we have one of our theorems. It talks about minor arcs. An arc is a piece of the circle. And two minor arcs are congruent if and only if their central angles are congruent. For example, up here, arc QR, this piece of the circle would be congruent to this piece, UV, because their vertical and their central angles are the same. Okay, that's what that theorem is saying. So let's talk about arcs. You have a major arc, which is anything that is a larger part of the circle. You have a minor arc, which is minor or smaller, and then you have a semicircle, and a semicircle is special because it is exactly 180 degrees. Arcs, you can find its measure, which, think about an angle, it's measured in degrees, or an arc has a length, which is a piece of the circumference. So we have two things with arcs we're going to have to keep straight. Measure, angles, length, circumference. Here we have an M in front, measure. So we're talking about how many degrees. So X, Z, Y. I'm going to use yellow so I can show you where that is. X, Z, Y. Okay? You have to go in the order that it told you. So that's halfway. That is a semicircle. And how many degrees will that be? That'll be 180 degrees. Okay, let's do letter B. WZX. Now notice I didn't just say WX because I don't know if that's this part or what part. So WZX, I'm going to go W to Z to X. So is that a lot of the circle or a little bit? It's a lot. It's most of the circle. So this is a major arc. How many degrees? Well, it's bigger than 180, but it's all of it but 90. So 360 minus 90, 270. And my last arc, XW, usually these arcs are always 2 letters. XW, that's just this little piece right here. So since it's a small piece, this is a minor arc. And we know its measure because of the angle right here. Its measure is 90 degrees. Super sweet. Okay, we also have another lovely little postulate. And it's saying the measure of an arc formed by 2 adjacent arcs is the sum of the 2 arcs. What does that mean? It means the measure of, let's say, arc XY plus the measure of arc YZ. We could add those two and come up with the big arc measure of XZ. Okay, that's what that means. We can add them just like angles. Example 3, let's remember back to pre-algebra when we talked about circle graphs. I want to find the measure of KL. KL is this red section of the graph. Now that does not mean the percent. It means the measure of the arc. How many degrees is this arc or the central angle? Well, I know it's 26% of the circle, so I could set up a proportion, or if you remember how to write an equation, you can do that. 26 over 100, because we're talking about percent, equals x over 360. If you want to set up the equation, we want to know 26%, so 0.26 of 360. Either way is going to get you the same answer. Multiply that out, and you'll find this measure of this arc is 93.6 degrees. A little more than a right angle. Okay, letter B, find NJL. Ooh, so I've got 3 sections. I've got 21% plus 37% plus 26%. I need to know how much is that whole big section. And that is 84%. So again, I can set up a proportion or I can do an equation. Let's do an equation this time. 0.84 times 360 equals how many degrees? 302.4 degrees. Awesome. All right, let's do one more with arc measure. Here we're going to find the measure of LHI. So let's talk about where is that? LHI. LHI, right here. I want to know how big is that? Well, LJ is a diameter. Since this is 90, this has to be 90 as well. So 90 degrees. Letter B, IJK. IJK. All right, we've got 90 plus a little bit more. Now I do know though, hey, look at this. This right here, This right here, they're vertical angles. Those are equal. Since this is 32, I can find this out by doing 90 minus 32. And I get 58. So this little section is 58 degrees, which means this little section over here is also 58. So how can I now find IJK? IJ is 90 and JK is 58, so let's add those two together and we get 148 degrees. Excellent. All right, so remember we talked about arcs can have measures, which is what we've been finding, or they can have length, which is an actual piece of the circle. It's part of the circumference. So we have here this length, not the measure, not the degrees, but the length. We can make a proportion. The length is a ratio of the circumference. So circumference is 2 pi r, and it's always going to be equal to x, which is however many degrees, over 360. This proportion is very important to remember. You need to remember it, okay? Let's use that formula over here in example 5. In example 5, I want to find arc AD or DA, and I highlighted it on the first one. Now the measure is 40 degrees, but I don't want to know the measure. I want to find the actual length. How long is it? So I don't know how long it is. This is L over 2 pi r. What's R? R is 4.5. And it equals x, which is your degrees, 40 over 360. Okay, so let's simplify down here first before we cross multiply. L over 9 pi equals 40 over 360. All right, let's cross multiply. 360L equals 360 pi. Divide by 360. Cancels. How long is this length? It's just pi, and it says to round to the nearest hundredth, so we need to actually round it to 3.14. Pretty cool. Okay, example B, same arc, DA. Show DA. I don't know though how big this angle is right here. I know that this is 28 and I know that this is a diameter, so I can find angle ABD by doing 180 minus 28, which is 152. All right, let's plug it into our proportion. We've got L over, now 2 pi r, this time we have a diameter, so we can just put 12 pi equals 152 over 360. Cross multiply. 360L equals 1824 pi. I like to leave pi till the very end, just so we're not rounding and it doesn't get messy. Let's divide by 360. And the length of that arc is about 15.92 centimeters. Okay, last one. we want to find arc AD again, DA, this little arc right here. All right. We know that it is L over 2 pi r, 6 centimeters, so we got 12 pi again, and 140 over 360. Go ahead and cross multiply. You are going to get 1680 pi equals 360 L. Divide by 360. And the length is about 14.66 centimeters. Okay. At the bottom, here's our 3 keywords that we talked about this section. Minor arc, major arc, and semicircle. Make sure that those formulas, though, we talked about arc length, that you remember that. Have a great weekend.